but we're gonna focus on friction in this case. Okay, so what we want to do here is like this. So we want to choose an object. Okay, okay. Let me stop here. So starting from position. So this time we're gonna put the friction in there. Okay, so there's gonna be friction. Okay, now see, it gives you those coefficients. And so what I want you guys to do here is the following. Basically, as the object moves, right, there are going to be totally three forces. See, there's going to be this normal force, gravity, and this pushing force. Okay, so I want you to let's see. No, okay, but when it start to move, you're gonna let me show it first. Okay, let me show this. Okay, so when you start to move, because there's a friction, so you need to make sure your force is big enough, because the right now it's 100. So it's 100 kilogram, right? So the static friction. So that means the normal force here is equal to weight, which is going to be 100 times 9.8. So it's 980 Newton, 980 Newton. That's the normal force, and then times the coefficient of static friction. That gives you the maybe let me just explain a little bit what's going on here. So again, I'm sorry I haven't got the written, but it's going to be exactly the same as I'm talking about right now. So what I'm trying to say here is, so when you have in this case, this is for lab 6. So what we want to do is this. Okay, so we have this thing here. Now, what in that case, we have 100 kilogram for mass, and then we use a pushing force F here equals to 100 Newton. Okay. Now, as you see here, the object does not move. Why? Because according to this setup, the coefficient of okay, mu k equal to 0.3, and the mu s equals to 0.5. Okay. So remember, the kinetic friction equals to mu k times n, and then the static friction equals to mu s times n, the maximum. Okay. So in order to get this thing in motion, it has to conquer the maximum static friction, which is mu s times n. Okay. In this case, you have mg going down and then n going up. So n simply equals to mg, which is 100 kilogram times 9.8. So that's going to be 980 Newton. Okay. So because mu s equals 0.5, so Fx maximum, the maximum static friction you have, is going to be half of this, so 490 Newton. So certainly if it's 100 Newton, you cannot move the object. Okay. So you have to increase your force to be big enough. Okay. So in this case, in my case, it need to be like 490 Newton. Okay, to move the object. So let's show it. Okay. Well, barely. Okay, so maybe let me increase a little bit, just a little bit larger. See, now it can move. Okay, because of that, because you have to be bigger than 490. So even if it's a 491, let's try 491 here. Okay. Okay, sorry, let's go back to the zero. See, even if it's 491, it moves, okay, because it's just a little bit bigger than the static friction. So the first thing I want you guys to understand from this lab is the maximum static friction, okay? So the force you use has to be bigger than the maximum static friction, okay? So I want you guys to try it for other objects in this lab. Okay, I'm going to ask you to try a few cases. What is the maximum force you need to use to move the object? Okay, now you can do a calculation first and then verify this. So the first part of the lab is going to be about static friction. Okay. So about this part, I want you to, what is the question is, what is the maximum force? sorry. What is the minimum force needed to move the object? To move the object. Okay, that makes sense, you guys? Again, you need to calculate the maximum static friction, and your force should be a little bit larger than this, okay? So I want you to calculate and then verify. Meaning that you enter that force in there, and then you can show that the object indeed move, okay? Is that clear? If it's clear, give me a thumb up. Okay, thank you.
Yes.
Okay, good. Okay, now the second part we want to talk about here is kinetic friction, okay? And as you notice here, as in our case that we talk about, the coefficient of kinetic friction is smaller than coefficient of static friction. That means if you apply this force here, I mean a little bigger than this, I mean, if you calculate, for example, in this case, if you calculate kinetic friction, it's gonna be 0.3 times 980 Newton. So it's gonna be smaller than 490, okay? So it's gonna be like 3 times 98. So 274 Newton. So it's gonna be smaller. So that means, but if you use this force to move the object, you have some acceleration here, okay? So let me put it back here. So let's say if you use like 491, you start to move the object, but then you're gonna have some acceleration, okay? See, there's gonna be acceleration. The reason you have this acceleration is after you get the object start to move, it becomes kinetic friction, and the kinetic friction is smaller than the maximum static friction. So in that case, you have some acceleration, okay? So let me see. So however, what you can see here is it does not give you the the friction. The friction it gives you is actually the static friction. It does not give you the kinetic friction that actually happening when you're moving, you know. See, it only give you this is the static friction you have, okay? So see when it moves, oh, so now this become while it's moving, this is gonna be your kinetic friction, okay? So what I want you to do, what you guys do is this, okay? So I want you guys to run again, to run these you have 5 objects here, right? To run 5 trials with the kinetic friction. Okay, yeah. So this here we need to run 5 trials as well for the 5 objects. 5 trials for 5 objects. Okay, this is going to be 5 trials as well. Okay. So what I want you guys to do here in this case is to get the for each trial calculate or measure. Okay. Okay. Calculate normal force and the kinetic friction. Okay, now for the kinetic friction is actually already give you that. So as we showed up already, so see you have it. Okay, so but there's a negative sign here because going this direction, when you write it down, you don't have to write it like negative. So you have the kinetic friction given, and for the normal force, as we explained here, according to the free body diagram, it just equal to the weight. Okay, so basically this one you can measure the kinetic friction, and then you need to calculate the normal force. Okay, now so you have 5 set of numbers of kinetic friction and normal force, and then I want you to plot it on Excel. So again, use this kind of a plot. So friction versus normal force. So what do you expect? So because we know Fk equals mu k times n, right? So we'll expect a straight line here, okay? We'll expect something like this. Okay, and then again, I want you to fit it and to get find the slope of the line. Okay, and this slope should give you nothing but the coefficient of static friction. So compare the slope to the compare with mu k. Calculate the percent difference. Again, I think it should be the same. I mean, it should be really close to zero, the percent difference, because these two things are the same. Yeah. So by doing this, you can see clearly that these two forces are proportional to each other, with the coefficient being the coefficient of friction. Okay, so sorry, no, let me see. There's a problem with this one. Yeah, the problem is, yeah, I guess you can only do 3 trials because these 2 trials have different mu k here. We can only do the three with same mu k, the cabinet and refrigerator and then textbook. So because they have the same mu k, so otherwise you get different answers. It won't be the same coefficient. So we'll only do 3 trials in this one. Yeah. But that's what I want to do. I'm going to write up the file right after we finish this talking, so that you have both of them there. And then I'll update the first one as well. Update for lab 5 based on what we discussed. Okay. So then you have lab 6, lab 5 and lab 6 both there. Okay. And then after that, I'm gonna start grading the tasks and also the previous labs. A lot of grading for me this weekend. So does that make sense, you guys? Okay, good. I see a sum up. So any questions? Okay. So okay, good. So let's start right here. On Monday, we're gonna talk about the task we did, and then kind of explain everything. And so, I mean, it's very important feedback to you guys to see that how well you're doing here, whether the way you would be trying to work everything out is efficient as it is, you know. So we'll talk about that. Okay. So let's stop right here, and I'm gonna start. Stop sharing this and then stop recording the video.